So I'll just copy everything from the form to start, and I'm going to comment things on and off as we go. Okay, so look at our form right now. Quite ugly. Let's start by taking a look at, well, line height is simple, but border none. What that will do, I'll make it bigger. If you look at the form down here, as I refresh, I don't know if you could see, but a border went away, the default border. Then what I'm doing is adding in a line at the bottom. And actually what will make this easier is if I just show you the finished app, just a moment, here you go. See how we have that white line running underneath? So that's what I just added in. It's very hard to tell because we still have the rest of the form there. So the next thing, let's make the background transparent. Okay, so it's easier to see even though it's very small on the screen right now. Now there's no white background. Then a couple other things. I made the fonts, get rid of that. Made the font size bigger, made the form or the input itself bigger, and then included a margin, a color, and some padding. Also, I'm using a class here. I could also just call this input, but what's being styled is not the form itself, but if you look here, we have a class equals form. So it's the input right here. Refresh now, and we're getting closer. Let's go back to 100. One thing that you may notice is when I click here, I get this annoying focus effect. We can get rid of that with CSS, which if we go to the bottom, we've got this input type equals text focus. And what this will do is say when an input with type equal text is focused, when someone clicks on it, there should be no outline. So if we save now and try it, I don't get that weird outline. Also, if you notice, I have the text white here. I don't know why I decided to do that. This is placeholder text is what this is. So as soon as I start typing, it turns white, but the placeholder is dark. To change placeholder text is a bit annoying. I'm not going to even bother spending much time on what this is, but if you notice, there's this fancy, basically it's a CSS3 browser-specific way of doing this where we're targeting the input placeholder text, and I'm setting the color to be slightly see-through. So now if I do it, oh, that's not what I wanted to refresh. Now if I do it, it's slightly transparent, but I start typing. There we go. Okay, moving on along. That takes care of our form for the most part. Now we've got the button. The button is pretty straightforward. Let me format this a little better. I'll just copy it all over and save. Mainly what I'm doing, we can actually get rid of this, is adding in a 3-pixel solid border. Then I'm making the font size bigger. I'm making the color, I'm changing the color, adding some padding, adding a background color, and then so the color here is referring to the text, a border radius to make it rounded, and then making it slightly see-through again. So you can see that change was made. I'm not a designer, so I'm sure there are many better ways, things we could do to just make this look better. I'm not terribly happy with it, but it's good enough for a MySQL course. So that's pretty much it for the button, which then leaves us with basically positioning things and formatting them. How do we get this to be centered vertically, roughly vertically in the page, which is what we did here, or what I did here. And it's not too bad. All that we need to do is change our markup a little bit. So we've got basically 2 divs that everything is wrapped in. The first one contains everything, and then there's a second one that also wraps around everything. The first one I just called flex container, and the second one gave a class of container. I'll just copy this and paste it over into home.ejs. But it's the same content. We've got our join us, we've got our paragraph, our form, but now we also have these 2 divs. And on its own, if I refresh, nothing changes. However, if we add in this little bit of CSS here, what this will do is help position things vertically. So we can put this, we can put it wherever we want, but I'll put it towards the top. Now if I save and refresh the page, now we've got everything vertically centered. So this isn't a course on CSS, so it's not a course on things like flexbox or positioning or what these fields do, but this is a nice and easy way to position things. Well, relatively easy. And so we're basically done here. Just to review what we did, the first thing that we did was to allow or to set up our app so that it was serving a public directory, which was this fancy line here. Everything inside the public directory is now available in our views. So what I'm going to do, I'm actually going to close down our CSS and markup so we just focus on what we actually have. So then in our home.ejs, we can link to app.css. We do need that slash, and it's referring to this app.css there. Okay, so then aside from that, we added a font, and then in our app.css, we added a bunch of styles, which we mainly copy and pasted. It's not the point of this course, but things like changing the font, adding a text shadow, changing colors, adding the background image, changing the background image size, how it's positioned or how it's sized, taking up the whole screen, but not, overwhelming it. And then also the font weight, making our font lighter weight. Then we've got our form and our button that we formatted, and then also we position things using these two divs and styling those. One thing that we could do to make this a little bit more kosher is to add a head and a body to it. So if you're familiar with HTML, you've probably been asking why we haven't done this. We should have it there, but we don't have to have it. A browser will add it automatically, but it's definitely an improvement to follow convention, to not rely on a browser to do that for us. So now we've got a nice, officially formatted, kosher home.ejs file, and just double check that it still works. All right, and let's make sure our form still works. No reason it shouldn't, but let's add in a jared@gmail.com. And we hit join now, and we see we've gone up to 506 now, and we could go over to MySQL, run the same query, select star from users, order by created at descending, this time limit 1, and we get jared@gmail, and we get the correct timestamp. And we're officially done with this app. So if you wanted to, of course, you could create a second page to redirect to that said thank you or congratulations, or you could, restyle this, or you could collect more information if you wanted a challenge. Instead of just an email, collect a name or a birthday or a phone number. That's more useful than an email if people will give it away at least. So this was a lot, 2 sections just to make this work. Although if we really think about it, the bulk of it was introducing things like Node and NPM and the MySQL package and CSS and HTML and EJS. So much groundwork for a simple web app. But the MySQL part was super easy, hopefully. Creating a table and inserting a single thing or selecting a count, stuff that we've been doing for a long time in this course. So hopefully you feel good about that. And this was more of just a high-level survey of creating an app, but I wanted you to feel like, you leave this course making something, even if it is simple, but you've now seen how all the parts fit together. Okay, so we're at the end of this project. All we have left is to style it. And it's kind of funny, I think for a lot of people, this is the most exciting part, even though it has the least to do with the course, but I get it. It's nice to have it something visual to make it look nice. If you know CSS, skip this. You can just copy the style sheet in, take a look at what I did. This is not going to be, like I've said a couple times, not a course on X. It's not a course on CSS. So what I'm going to do is, rather than spending 2 hours of video going over, styling this one piece at a time and talking about my workflow and why I'm doing certain things, what I've done is just copied over the finished style sheet and our finished markup. But we still have our empty markup or our basic markup, and we don't have a style sheet. So what I'm going to do is just walk through and kind of copy bit by bit over and explain what chunks do, but not everything. And these 2 files you can find yourself. They're not in the slides, they're too large, but I've included them along with this video so that you can copy from there, unless you're someone who likes to type things manually, which some students do. Okay, so again, these are 2 files that are not connected to our app. These are the solution files I'm going to refer back to. But for now, we're stuck with this, our basic HTML, and we don't even have a way of styling it. And for those of you who don't know CSS or know what it is, it's how we add style, color, font, images. Well, not how we add images generally, but it's how we can add a background image to something using CSS. And the way we usually write that is by creating an external style sheet a CSS file and writing our styles in there like this. So we need a way to actually connect them. And I'm not going to go into too much detail, but so usually what we do looks like this. We'd have a link, rel equals style sheet. This is an HTML tag that includes an external style sheet. So if I do that and I just paste that in here, there's two problems. One, we don't even have an app.css created, but two, Express isn't going to know about it. Hi, Blue. What we can do is start off by creating a new directory. And this is just a conventional name. I'm going to call it public. That's kind of standard for a web app, but you can call it whatever you want. And inside of there, I'm going to create a file called app.css, like that. And then we'll put our code in here. And let's start with something really simple, like turn the whole body, make its color purple. So all our text is purple. Oh, like that. Color purple. Ow, Blue. Hey. My cat just attacked me. Hey, why don't you let me record, okay? Hang on, I'll be back. I gotta handle this. All right, that's been handled. Crazy cats. So back where we were, we've got our app.css, body, color purple. This is not connected to our app. If it were, then our text would be purple, but it's not. So how do we get it connected? Well, there's a problem. Long story short, we need to add this line. So this is another app.use, and this tells Express, if I go into our main file here, app.js, just add it with the other app.use, keep all our configuration, and it's basically saying, take whatever is in the public directory, which is right here, take all the contents, and serve them so they're accessible by our views, or from our JavaScript. So now, if I restart the server, app.css is going to be available to this file. Hopefully. And if we refresh the page, we now have purple text. Okay, so we now have a style sheet connected. And if you had, just as a quick aside, if you had multiple different views here and you wanted them to have the same style sheet, you could use this line in all of them. Or there's actually a better way, which I'm not going to talk about in this course, called partials, where you can basically have code that runs on all of your views. But you could also have a separate style sheet for different views if you wanted to. Just put them all in public. Okay, so that's the first simplest thing. The next thing you'll notice in the finished markup is there's also a Google API or a Google font that I included. So I'm going to put that in here too. This is for a font called Roboto. Pretty common one. If you're not familiar with Google Fonts, really great resource, free fonts that you can use on your own websites, and they look good. So now let's also go back to our finished CSS, and let's copy some of this body stuff over. For example, font family. Let's start with that. So we don't want things to be purple. We can get rid of that. But let's change the font so that we now are using that Roboto font. There you go. Our font has changed. Slowly getting there. Next thing that we'll do, if we go back to our CSS, is we'll take the color and the text shadow and the text align. So I don't need font family again. I'll get rid of that. So line this up. Okay, so this color is like a slightly purpley gray, if I remember. And we've got this slight shadow, which I don't know if you could pick up on the original. We're getting close. Well, that's a lie, but we're getting close to being done with body. Then we've got a couple other things. First off is the background image. And if I just show you this image in its entirety, it's a massive image of beautiful mountain in Argentina, down in Patagonia, that I took on a backpacking trip. It is called Cerro Torre. And yeah, that's my little plug for my photography. Maybe I'll have a photography course one day. So here's this photo that we'll use. We just need the URL. And we're setting the body's background image to that photo. Save and refresh. And it worked, but you can see it kind of just looks like a solid color. But it's using the image. It's just so big that it's taking up the, I don't know, 5 or 6 of these screens or more. So that's actually something that if this is a real app, it would be good to just use a smaller image so we're not loading such a big image. But what we can do is use background size and set that to be cover. And now it will basically take the image and make sure it covers the entire background. So we've got that. It's getting a little closer now. The next thing that we can do, if we scroll down, we'll come back to this flex container. We've got our H1s and our paragraphs. And if you notice, I'm setting the font weight to be 100. I'm actually going to get rid of that in both of them. There's a better thing that I can do, which is just set the font weight to be 100 in the body. And what that will do is just make our font thinner so that we get this thinner text. Okay, so we've done that. And let's see, moving on, let's work on the H1 next. So the H1, this giant, or well, it's not giant yet, but this join us that will be giant in a bit. We've got a couple things that we're doing. We're setting, well, let's just copy it all over. Margin to be 0, font size 500 pixels. Line height is 400 pixels. Okay, so it looks massive right now, and that's because I'm super zoomed in. So it's not as massive now. It still is big, but nowhere near as bad. So we've got join us, and that's big, looking relatively good. What we want to do, of course, is position it downwards, but I'm going to wait to talk about that. So we'll move on to the next thing. We've got our paragraph that we can style, and really all we're doing for the paragraph is changing the font size. So this here gets bigger. Then after that, we're onto the form and the button. Okay, so picking up where we left off, if you remember in the last video where we got the HTML up and running, the EJS file, I said ignore the form for now, we're coming back to that. Well, now is a video where we're going to get that form working. And it involves a couple of new concepts, so hang in there. The MySQL part is the same. We've already seen how to insert. If we go back to this early, where is it? Here we go. We've seen how to insert this single file. We inserted this single Rusty the dog. We also saw how to do it with this object syntax. And then we saw how to do a bulk insert with a lot of them, which we don't need to worry about. So we've seen how to do this. Now we need to figure out a couple things. One, how do we get the data from the form? This form here, unstyled, so this form. A user types their email and it hits join now. First of all, where do they send that request to? We need to figure that out. And maybe you guessed this, we need to define a route for that. But there's a slight difference in that route, which I'll get to in a second, because there's another problem, which is how does that data from the form get there? Well, what we want to do is use what's known as a post route. So there are different types of requests. I briefly touched on this get and post request. This is not a course in HTTP, so you'll kind of just have to take me at my word here that we need to use a post request because it allows us to send data with the request. The form will automatically take the data from here and send it as a post request to the destination that we tell it to send it to. So let me show you how we do that. We've already seen, we deleted it, honestly, from the form, so there's no suspense here. We create a form element, and the first thing we can do is add in method. And method we will set to be post. It can be all caps, all lowercase, it doesn't matter. You'll see both. And that is saying that when this form is submitted from this button, the last button, or if a button is the last thing in a form, it will automatically submit the form. So when it's submitted, it's going to be a post request, and we'll send it to a route that doesn't exist yet. So we send that with action equals, and then we could send it slash, but that would just redirect us back here, except that needs to be a get request, so we'll get to that in a moment. But we could do slash register. We'll make up a route that doesn't exist. So right now, this form is going to take us to a page that doesn't exist. And if I try it, massive. Oh, this is still much bigger than it is in reality. It's about this size, but that's harder to read, so I'm just increasing the font. So if I enter something in here, blah, I click join now, it tells me cannot post to slash register. Great. So we need to define a post route to slash register. And again, the reason we're doing post is it allows us to send the form data. But what I could also do, if I did a get request, I'll show you what happens. We already have a get route defined, a couple of them. Let's do a get request to slash joke. So what that means is that when this form is submitted, it's going to send the data to slash joke as a get, which we already have That's what this get comes from, app.get/joke. So if I restart and try it again, this time if I enter whatever there and I click join now, you'll see it takes me to /joke. There's also a question mark here, so that's something to consider. What's happening is that our data isn't being sent because we're not giving it a name to be sent under. So what we do is assign our input here a name. And this will be the label for whatever this is right here, which is email. So that's the best thing we could put there, email. So when our data is sent off by the form, it will be referred to as email. And there's only one piece of data that we need. If we had multiple things in our form, we might have email and first name and last name, and they could all have a name. So now if we do it, actually don't need to restart the server to do that. But now if I do blah@gmail.com and I hit join now, notice that my URL, it's hard to read, but it says /joke. We sent a get request to /joke, and then it appends email equals blah, %40 is what it's doing for the @gmail.com. So you can see our form data is making it here to a different request, but this is not a post request. And we want it to be a post request for really the main reason is that we don't want our data just to be appended like this in the URL. We could get away with that. The standard way of sending data from a form, if you're adding it into a database, is to do it as a post request. This is known as a query string. There's a lot of terminology here. This doesn't matter. We don't want it to work this way. I'm just telling you that it's not a conventional, it's not a good practice. If you're doing like a search form or something, this makes sense. And you may have noticed search forms and search results will often have query strings after the route. We don't want that. We want to send our data using a post request, and not to /joke, but to /register. Now the problem is, how do we create a route that will listen for that? Essentially, what we're trying to do, back to this handy dandy animation, is something like this. Hello server, I would like to sign up. Here's my email. Pass the email to the server, and then our Node app, our Express app, is going to take that email and run an insert query with MySQL. MySQL hopefully says, great, it worked. Then we get back either something like this, a thanks for registering page, or we just redirect back to the home. So we'll decide on that. So how do we get the Express app, the right side here in the green, to accept this email, or to even know that a request is being made to /register? With this, app.post. This is how we define a post route. Just like a get route, except it's app.post, everything else is the same. So let's do that now. App.post /register, which needs to match whatever we put here. So if this was registration or create user, then this needs to be registration or create user. And our same request and response. This will only be triggered when a post request is sent to /register. So just to prove that, let's do a console.log post request sent to /register, just like this. And now if I restart my server, I have to go back here. If I submit this form, I'll make it take up half the window here. Watch down here, and I go here and I type whatever I want in here and I click join now. Notice that we get our post request sent to /register. And if I try and get there another way, like by just going to /register, this is sending a get request. We haven't actually discussed that, but when you just go click on a link or you enter a URL manually, that is sending a get request. And that's why it's telling me it cannot get /register. So essentially the only way that we're going to be able to, in practice at least, that we'll be able to get to this route here and trigger this code is through the form. So one more time, put something in here, watch down there. A post request is being sent every time. So what we want to do now is be able to extract the data that's being sent. And for now, you have to trust that it's being sent, that our form data is being sent. We don't have a way of seeing it. And the way that we see it, oh boy, it's a little bit complicated. I'm going to walk you through the steps here. This is the annoying setup we have to do. So we have to install something called body parser. And I won't waste much time talking about it. What's happening is that Express is a lightweight framework, which means that it doesn't come with everything that you would possibly want. pre-installed, so we have to go and select certain things, and body parser is one. What it does is it parses the request body. So remember that when a request is sent, there's all this, it's just a giant block of text, and somewhere in there it says email is equal to whatever we typed in here, but it's in a giant block of text. It's not JavaScript or anything. So body parser will intercept that and turn it into JavaScript that we can then use and manipulate. So then what we need to do, and I'm just doing this quickly, it's just copy and pasting, importing body parser equals require body parser. So we can save that. Make sure our package.json has body parser in it. Then finally, we need to tell our app to use it. So I'm also just going to copy that line and put it next to app.set, so we have our configuration lines together. We're not going to go into detail on this line, but this is just requiring body parser doesn't do anything. We have to tell Express, which is app, right? App is from Express, that we're using body parser. And this now allows us to extract information from post requests. And here's the magic line: request.body.email. So what this will now store in the request body in that post route under email will be the email address coming from the form. So let me show you that. If we go to our post route for register, rather than console.log post request sent to /user, we'll also add plus request.body.email. Email is, how about that? Request.body.email. Okay. So we definitely need to make sure that we have name equals email, and then we should be good to go, assuming our install went okay. Let's start the server again. It looks good. Let's go over here. Just going to refresh this page. Now I'll type c@gmail.com, join now, and what do you know? Post request sent to /register, email is c@gmail.com. So whatever is typed into that form is being stored in request.body as email. So body parser is doing the heavy lifting for us here. We had to do kind of a couple of annoying lines, but let me show you what body looks like. So request.body on its own. So I'm going to comment that line out. We're not console.logging anything. Now, if we go back to the form, refresh, and I type, h@gmail.com, and I click join now, this is what our request body looks like. Email is h@gmail.com. Again, email is coming from here. But if I get rid of body parser, let me show you what life is like without it. And I do the same exact thing, h@gmail.com. Now there is no request.body. It's undefined. I did everything else the same. So just this single line telling our app to use body parser is what allows us to access request.body. So the information is still being sent to Express, but Express is just not doing anything with it. Request.body is what we need, along with this body parser line, to start using it. So it's kind of confusing, but that's the whole kind of ethos of Express, is that you add the tools you need as you need them. So rather than giving you everything at once, and you might only use 1 out of 20 things, it gives you one thing, 2 things, and then you go and grab the other things you need. So if you need post request and you need a request.body to be filled in with data, then we need body parser. Okay, so then all we really need to do now, if we're isolating request.body.email, that's the email that's being sent. Let's save it to a variable. Now we just need to insert that, make a new user, which we've already seen how to do, and I won't make us type it from scratch, but hint, hint, we're going to be doing connection.query, and we've already seen how to do the query. It's going to be an insert into. If we go back, let's just copy this code here. This is what we've done in the past, where we inserted a single user. Go to app.js. So I have it commented out. I'll uncomment it. There's a couple things we're doing. The first, I made a variable called person with an email and created at, but we don't need that created at anymore because this was for Faker. We actually have a real created at, and then for request.body.email, we can just replace that. Okay, So we can get rid of that variable too. So this is just preparing the data to be inserted. We'll have a person object that has an email, request.body.email. And then all we need to do here, we don't need to store it in a variable, is just connection.query, insert into users, set, we pass in person, and then we have our callback function. So this is review. We've already seen how to insert, so I won't spend a ton of time on it. We can start by just console.logging the result, which will be a lot of stuff, hopefully. Let's see what happens now. We have body parser working again. Okay, good. Now, if I go over here, this time it will insert a real user. So let's do a more serious email address. Well, I guess that doesn't matter. How about Miranda? Let's not do all caps. Miranda54 at hotmail.com. Miranda. There we go. Join now. And look what we get back. Affected rows 1. It says OK packet. All this other stuff. And if we went into our MySQL, if we wanted to do a select star, well, it's going to take a bit. We'll have to type it ourselves. Select star from users, order by, created at, limit 1. We don't have a users table in all caps, oh boy. We get the wrong user, scared me for a moment. We need to also change the order at, or order by, created at, to be descending. And here we go, Miranda54 at Hotmail. So it worked. Long story short, it worked. And we're pretty much done. The only other thing we have to decide is, okay, our web apps is just kind of hanging here. You can see that. What do we do next? And we could either do something like a res.send, thanks for joining our waitlist, let's say. We can start with that. And if we restart the server, do it again, have someone try and sign up with a new email, let's say Jane Doe at gmail.com. Click join now. Now we get thanks for joining our waitlist. So it's totally up to you how you want to structure this part. What I'm going to do is just have it redirect back to the same page, to the original page here, and we'll be able to see 503 or 504. It's really up to you. This is how you wouldn't use res.send, but you could do a res.render, and you could make a thank you page if you wanted to. But what I'm going to do is show you another line, which is just res.redirect. So res being response up here, res.redirect to /. And that will just take us back to the home page. So effectively what's happening, if I restart one more time, is we're on the home page. 504 is how many we just got from the database. I entered a new one, Dave at dave.com. I click join now. It's going to hit this post route /register. We're extracting the email from that form data in the body, and then we're inserting it as a new person or new user in our database. When that finishes, we're redirecting back to /, which starts this whole process over. It's going to then select all the count of all users. Then it's going to, oh, there's my cat. Then it's going to render our home page with that count. So to the user, it will just look like this page refreshes, and this goes from 504 to 505. But behind the scenes, a lot more is happening. And there we go. Okay, so that's awesome. Hopefully you think that's cool. All we have left is to style it. If you would like a little bit more detail on the insert part, and I can go over that a bit more if you'd like and what's happening here, but if you feel like you've got a grasp on it, you want to move on to styling, go ahead. Okay, so just to reiterate, we could have also done it a little bit more manually if we wanted to. We could have written a query like this. If I did var query, and I could have done insert into users email, so this should be more familiar, values, and then I would do parenthesis plus request.body.email plus closing parenthesis like that. And that could be our query. So this would turn into, let's say request.body.email is dave@dave.com. It would turn into dave@dave.com like that. So we could also do this query this way, and then all we would need to do is pass Q right here, if that makes sense. So that's another way of doing it. But this is kind of the standard way of doing it with the MySQL library, or the MySQL package that we've been using. So I'm going to get rid of that. But either way, maybe the syntax is more unfamiliar if you don't know JavaScript, but this is what we already saw as to how to insert a single piece of information, a single row into a table. And it's working. Great. Okay, so now what we're going to focus on is actually getting HTML implemented with our web application. So right now we're responding with these little ugly things of text like this. And before I go too much further, just another note. If you know HTML, great. If you don't know HTML, you'll just sort of have to hang on for the ride here. I'm sure you've heard of it. Well, I guess hopefully I'm not assuming too much, but you've come across HTML. Every web page you look at is built with HTML. Behind the scenes, there is this markup language that is dictating what elements go where. And then there's CSS, which we'll get to later, which makes it look pretty. So what we're going to do is focus on writing HTML so that we can have things like a form and a button, or we can have large text, which is known as an H1. And we actually can do that right now in a really hacky way. So let's say rather than just, let's do it for my joke. What I could do is make this joke italicize part of it. So I'll say, what do you call a dog that does magic tricks? And I'll italicize the answer by putting around it the EM tag, which is how you make things italicized. It stands for emphasis. So if I just put HTML inside of this string, and actually I can make this bold too, so I'll do strong. First thing you should notice, if you've ever written HTML, this is a horrible way to write it. Instead of a single line like this, it's just not a good experience. So we're going to see how to get around that. But I'm more just showing you it's possible to have HTML in there. So if I go to /joke, you can see I'm getting HTML. That's being rendered properly. So if we wanted to get like a form on our homepage, which is what we want eventually by the end of this video, we could put all the HTML to make a form inside of this string, but it's going to be significantly longer than this. So we're not going to do that. And there's a bunch of reasons why. The main one is that it's a pain, but it's also hard to change things, and it doesn't really allow us to style it with CSS when we get there. So to jog your memory, this is what we're working towards. This is what our app will look like. We have a big background photo of a beautiful mountain in Argentina. Then we've got join us, big text, different font, different color. Then we've got this other text, enter your email to join 500 or whatever the number of users is. Others on our wait list, we are 100% not a cult. And then we have a form with a single item in it, or a single field, a text field, and then a button that will submit the form. But if we strip away all the pretty styling, all the makeup or paint on top, this is what it looks like. This is, the bare bones of it. So this is what we'll get to by the end of this video. So this will be our home page. We're going to replace the content here, this single string, with this. And to do it, there's a couple steps we have to take. So here is the HTML itself. If you don't want to type it, this is the HTML we need. We've got an H1 that says join us. We got a paragraph. We'll come back to this class. We don't need that actually right now. But then we've got enter your email to join, strong, which is the bold, around 518. Then we've got a form, which we'll also come back to. So I'm just showing you this is all we need to actually make the HTML, or the correct HTML to make that page. Now, how do we actually get this to be sent back? What we want is, in this route, when you go to / basically give the user this. But we can't just make that a single string. So what we do is use something called EJS. And you'll have to bear with me here. There's a couple of steps we have to go over. And if you're new to web development, this will be a bit intimidating, possibly. It's probably a terrible thing for a teacher to say. But just hang in there. Just know that we're going somewhere. And some of the steps along the way may be confusing, but once we get there, it won't be too bad. So EJS is what's known as a templating language, stands for embedded JavaScript. It's an alternative to writing just plain HTML. It allows us to add in variable values and code logic. So this is, where's that slide? If we go back here, this is HTML, but this right here is not always 518. So we couldn't do that in a normal HTML file. we would want to be able to say, okay, this is HTML, but right here in that strong tag in the bold area, there's a variable, but you can't do a variable in regular HTML. So that's what we're going to use EJS for. It stands for Embedded JavaScript. It's just HTML that allows you to embed JavaScript inside of it. So we'll see how to do that in a moment. But the first thing we have to do, npm install -- save EJS. This is to, you should know by now, hopefully, that this is going to tell our app and our package.json that we want EJS installed, and it should install it and save a record to package.json, which you can see now we have EJS there. That's our first step. Then we're going to do something else. This is configuring our Express application, app.set viewEngine, EJS. So app.set is a method that allows us to set certain settings in our app. ViewEngine is the most common one to change. There are other templating engines. There's things like Jade, which is a common one, Haml. There's other languages. So basically they are similar analogs to EJS. Okay, so we'll go do it at the top. It's a traditional place to do it. Just like we're setting up, our connection up here, it makes sense to set and to configure application-wide things up top. So we'll do that. And then the next step is, okay, where do we actually start writing these files? And to show you that, I'm actually going to work backwards. So the line that we'll be running in our route that will actually render a file is res.render some string, in our case, home. And the process that will happen behind the scenes that Express doesn't really show you or tell you about is it will automatically look for a directory called views. That's a standardized name. So it's going to look for a directory called views. You can change that if you wanted to, but we're not going to. And inside that directory, it's going to look for a file called home dot whatever the view engine we said, which is EJS in our case. So it's going to look for home.ejs in that views directory. So what that means is we need to create a views directory, and then we need to create a file. We'll call it home, but you could call it landingpage.ejs or root.ejs. Whatever it is, you just need to remember the name. So let's do that now. We'll do right click, or you could do make directory if you're more comfortable with a terminal. New folder, views. Inside of there, we'll make a single file, which we will call home.ejs. Again, you could call it whatever, as long as it ends in .ejs, and you remember what you call it. And we'll start with a single h1. We'll just say this is HTML and save it. Then we go to our app.js, and let's just work with our root route. Rather than sending res.send, we have count. We're no longer working with res.send. We have a res.render home. I'm going to be a broken record, but it's looking for home.ejs because we added this view engine is EJS, and it's looking in views by default. So we need to make sure we have that file. It's going to take the contents of this file and send it all back. Rather than a single line, we can write our code now in a separate file. So let's see if it works. Start our app. Let's try going to the home page. There we go. This is HTML. Our other pages still have, well, this one is HTML, but it's not coming from a separate file. Okay, so then what we can do next is I'll just show you. You could, use res.render home. You can send the same file in all of these instead of res.send. You can reuse files in different routes. It doesn't matter. So here we have the same thing for joke. So if I go to /joke as well, I get the exact same thing. Okay, so these don't care about what they're called. The name of this has nothing to do with the route, although it should if you're just following best practices. Okay, I'll get rid of that. So now let's just copy the HTML that I provided here so that we don't have to type it all ourselves. So in home.ejs, I'm just going to paste this in. We'll go over what some of this is, in particular the form we haven't talked about. But let's just get this in here and see how it works. So we have to save the file. Now we get our form. So we have join us, which is our h1, which is what we started with. Then we have a paragraph. Again, don't worry about the class at all for now. You can actually just get rid of that if you want. Just focus on keeping it simple. Then we've got enter your email to join inside the paragraph. All of this is in the paragraph. There we go. 518 is hard-coded for now. We're about to replace that. We are 100% not a cult. And then we've got this form, which we're just going to ignore for now, except know that there's a text input and a button, which we get. That all looks good. And in fact, we can clear out that form and just leave it like this to start. Okay, so now what we want to do is figure out how we get our data in here. Because right now, this is just plain HTML. There's no use for this EJS stuff that I was talking about. But the whole point is that we want this to be 519, 520, 499, 10,000, whatever the result of this is, whatever count is. But how do I get count, this variable, over here? What we do is after res.render, we can pass a comma and pass a JavaScript object, and I'm allowed to pass data through. So what we want to send is count, but first I have to give it a name. So typically you'll see something like this, count, count. Rather than that, I'll do data is count. I'm going to change it later, but just to show you they're distinct. So what this does now is it says, okay, take count, whatever it is, which last time we counted was 501, send that to this template and give it the name of data. Basically put it in an object under the key of data. So inside of here, if I refer to data, it will be referring to whatever count was. The problem is I can't just say data. If I just do that and refresh, we just get enter your email to join data, others on our wait list. So I need a way of saying, hey, this is not HTML, this is special, this is code. And the way we do it, it's weird if you've never seen it before. It looks like this. So we have brackets, just like we would with HTML, the angle brackets, but then percent equals, and then percent on the closing side. And this is basically a signifier that says this is not HTML. Whatever is in here is going to return a value that we want to put in the HTML. So if data is equal to 500, it will be replaced with 500. If it's equal to 12, it will be replaced with 12. Kind of a lot to take in, as I was saying. There's a lot of moving pieces here. Unfortunately, we don't really have time. I guess we could have time, but the course isn't on EJS. It's not on web development. This is just a vehicle to showing you how to make something. Okay, so data will be count, whatever's coming through there. Let's try it. And we've got 501. And of course, we could insert one more user very quickly. Let's do Austin 234. Refresh our page. Now it's 502. So we've accomplished our goal. If you feel comfortable with how it's working, go ahead, stop, move on to the next video. If you have a couple of questions though, I'm going to go through the process again. I'm not going to recreate it, but I'm going to step through what's happening. So we'll start with this app.get / that's activating the route when I go to this URL. We still have our /joke, for instance. But we're talking about the root route. When I hit that route, first thing that happens is this code runs, which the end result is it figures out how many users are in our database. It's running this code in our database. Select count * as count from users. That's coming back, stored in results. Inside of results, we're finding it. The reason it's stored under .count is because of this as. So if I called this counter, then this needs to be .counter. Okay. So then we're storing that in a variable called count. So this has something like 501 in it. Then what we're doing, we can get rid of this line now, is we are rendering the home.ejs file, which is automatically looked for in the views directory, which is right here. We have a bunch of HTML in here, some of which we haven't talked about yet. But then we have this one variable with this very weird syntax that we haven't seen before. This is our way of saying, hey, this is not HTML. This is a special value. We can put JavaScript in here. And just to show you a couple other things, I'll do another H1 and then our funky bracket thing again. And I can actually just do simple math in here. Let's do something like 4 times 98. This will run as JavaScript. Whatever the result is, I'm terrible at mental math, will be printed there. So if we refresh our page, we get 392. And we could also pass in, another piece of data like favorite color. And I'll just say it is purple, which is true. It's my favorite color, highly underrated. Pass that in. Over here, I can refer to favorite color. Why we would do this? Well, that's another question, but I'm just showing you that, oh boy, here we go. Favorite underscore color. We have access to whatever we pass in here. So favorite color is the string purple. I will need to restart the server if we are changing our app.js file. Now we get purple, it's coming through. So the only difference is that data right here is not something we're coding in ourselves. We're not hard coding it. It's coming from the database from all this work, running the query and then basically extracting the data out, saving it into the count variable. And the last thing I'll do is change this to be count, because data is just a bad name for a variable. Everything is data. But the reason I called it data again was just to kind of show you that there's a difference. It can be confusing at first if you see count, which one is which. This is the value we're passing, and this is the label for it. This is the key. Okay. So let's just make sure it's still working. Refresh. Enter your email to join 502 others on our waitlist. We are 100% not a cult. Perfect. We're done. Okay. Welcome to this big step. What we're doing next is integrating MySQL into a web app. So we saw, again, how to integrate MySQL with Node in a single file that has nothing to do with the internet or web applications or servers or routes, where we just inserted 500 users at once. Now what we're going to do is take our web app that we've created, super simple, unstyled, but something like this. When we go to the home page here, right now it says you've reached the home page. What we're going to try and do is take it to this. We have 519 users, and that 519 is not hard coded in. That's coming from our MySQL database with the 500 something that we inserted. So this will change depending on how many users are in our database, and we'll see that that works. So to do that, I have another diagram that took ages to put together. I apologize if it's the colors aren't perfect or there's not nice typography. I wish I was better at that stuff. But here's our trusty red rectangle that represents a client computer. Here's our Express app, this mint green. This time we're requesting the home page / the root route. We ask the server for it by going to this URL, hitting enter. The server says, oh, hang on. It says here that I need to ask MySQL for a user count. Okay, so MySQL is now involved. This arrow represents the connection between Express and MySQL. We've already seen how to do that, how to connect MySQL to a JavaScript file. We ask, basically with a select statement, select count from users. We get a response from MySQL. Hopefully there's not an error. We get a response 519. Then our Express app can take that and say, okay, we're all set now. Here is your final result. Here's the page we get. We have 519 users. All right, so there's a couple steps involved that we need to do. Basically, it boils down to, we've already seen how to make a simple route, and in the last section, we saw how to connect MySQL to a file. Now, we just need to combine them together. So the first thing that we'll do is go over to Cloud9, and we need to connect our app, this file, to our MySQL database. And what we can do is just go to our previous app.js and just copy this code, var connection equals mysql.createConnection. So I won't make you watch me type this whole thing again. But remember, this is using the MySQL package, and we already installed that earlier. We ran npm install --save MySQL. If you didn't do that yet, go ahead and do it so that you see it here. And that inside of our join us folder, inside of node modules, we have MySQL. We need that. But we're still missing something, which is we need to require it. var MySQL equals require MySQL. So this is all review. We did it earlier when we made our seed data that inserted 500 users. So we've got this, and let's just make sure that that works without problem. So we'll just start node app.js. Everything looks okay. All right, so now we can focus on interacting with the database now that we've connected to it. But just to reiterate, this database name needs to be the name of the database inside of your MySQL server that you created with the users table. So it's the same as what we were doing earlier if you've been following along. If you named it something else, this has to match. So what we're going to do is, instead of you've reached the home page, we want to find count of users in database, and then we want to respond with that count. So we've got a res.send. Eventually, what we're hoping to do is have something like we have plus count plus users in our database, or something stupid like that. That's what we're hoping to do. Of course, right now we don't have this count variable, so that's what we need to aim to get to. So I'll start by commenting that res.send out. So to find the count of our users in our database, we need to do a connection.query, which we've done before. Remember, it's all the stuff we were doing over here. Connection.query, connection.query, connection.query. And what is the query we want to write? Let's do it in a separate variable. So var, I'll just do q again, equals a string select count star from users. Just like that. If we were to just copy it, go over to our MySQL, we get 500. Okay, so that's what we're hoping to get, but of course through JavaScript. So we've got our query written as a string. Now we just pass it in, connection.query. Then we add in that fun callback where we have error, and let's call it results. Okay. So whatever code is in here will only run when two things happen. First, when somebody requests slash. Then we have to wait for this connection to run the query, which is select count from users. So then when that is done, whether it worked or not, this code runs, and there will either be an error, so we can add our if error, throw error, which is not actually a great thing to do in a web application. What would probably be better is to say, if there's an error, what do we want to do? Redirect the user to a different page or send them a different response, which we can see how to do in a little bit. But we're just going to leave it as that to keep it short. And then otherwise, let's do a console.log results and just see what we get. Okay. So again, to go over this, we connected to our database. Then only when somebody requests slash are we trying to select count from users. We could do it inside of joke if we wanted to, or random num, but the way that our app is going to work, the home route, when we go to the home page, we see, welcome or join us, join the 519 users or whatever it is, and then there's a form at the bottom. So we're just going to do it on the home route. Let's see what happens if I try running node app.js. Looks like we have a syntax error, and that is because we're missing parentheses around error there. Okay, now we're good to go. Now if I try and just go to the home route, not joke, well, joke will work just fine, but if I try and go to the home route, what do you think will happen? And the answer is that we're not responding with anything. Assuming we don't get an error, we're not actually responding with any res.send, so we're not going to see anything over here. It just waits and waits and waits until it gives up. So I'll stop it here. But notice we get this row data packet, a single array with one item in it. So we're going to want to do result 0. And then what is nicer is if we give it that as alias. So we'll say select count as count, just like that. So now if I start the server up again and I refresh the page, this time we get row data packet count is equal to 500. It's inside of an object, so all I need to do is do dot count. So this will print 500 now. So let's save it to a variable, var, and we'll just call it count as well. So now we have a variable with the count in it. So then the last step, and I'm going to get rid of this pane here and just work over here. But now that we have our data coming back from the query, we're going to want to do a res.send. Now, something that trips people up, is when you're working with callbacks like this. It might seem like this code is going to run after this, but in fact, we have no guarantee of that. What we want to do instead is only run it inside of this callback. So this is a very common pattern in JavaScript, and in Node in particular, is that you have these nested callbacks. And it can get out of control sometimes. There's something called callback hell, but this isn't too bad. It's not bad at all. So we have our route, app.get. When this route is hit, run all of this code. Inside of there, we're defining a query. And we're doing that query, and it takes time. It might take half a second, although that would be pretty long, but it might take, a tenth of a second or something. And so what we want to do is wait until it comes back and run this code. If it's an error, throw the error. Otherwise, select or isolate the count from the results. Then we do a res.send. We have space count space users in our database. Let's try it. And there we go. We have 500 users in our database. And to prove to you that it's working, let's go over here. Let's do an insert into users. And we'll just do an email. And we'll do something we haven't done. So unoriginal here. Austin at gmail.com. Still struggling with the originality there. So we'll insert that single user. Okay. So there now should be 501, and we can double check. And it works. Note that we didn't have to restart the server or anything. That would kind of defeat the purpose if our data was only refreshed whenever the server restarted, because we're going to have people interacting with this. When we set this app up and we finish it up, it will just be left running, in perpetuity until, we have to fix something, or we launch our startup app. So it will be waiting, just running constantly. So our database will be changing all the time, and it has a connection to that database. It can kind of check in with the database, see how it's working, what's going on, and get the results back and do something with them. So still very simple, but it's a start. So we're connecting with our database. The next thing that we'll need to focus on, which will take us a bit to get there because we have to create the form and talk about HTML and a thing called EJS, but our next goal is to also run the insert query that will insert a new user in. But like I said, to do that, we have to set up the route that will insert, and we have to set up the form to actually do the insert for us. But that's where we're heading. Okay, welcome back. So in the last section, we saw the syntax to add a single route to an Express app. Our app has one URL that you can request to get a response. Everything else, we get that error message that says cannot get, and then whatever you tried to get, whatever you tried to request. So we'll try fixing that now. We're going to add some more routes. So the first one we'll do is going to be silly. It's a joke route. When you go to /joke, it just gives you a joke. Rather than just doing hello or hi or goodbye, we're doing a joke. So when we request from a computer or from a phone even to our URL, and then we have our Express app that we're requesting, this time our request is, hey, I would like the /joke page. So that's like this. Rather than just hitting enter here, we would go to /joke. And yeah, you're usually not, typing these URLs manually. You're clicking on links. So maybe there would be a link that takes us to /joke. Just as there are links down here. This is an error page for Cloud9, but there are links. Each one takes us to, this one is c9.io/support. If you can see that in the bottom left, very tiny. Here, you can see /support. So there's code that is listening, that's taking this /support, and it's figuring out, oh, we need to show the support page, the need help, all these buttons on support. Anyways, so we're going to ask for /joke. Our Express app is going to say, sure thing, here you go, and send back a really stupid joke. What do you call a dog that does magic tricks? A labracadabrador. I had to pick something that is politically neutral. It's not going to offend anybody. So we're just going with labracadabrador. So to implement that, it's very similar to what we've done. We just basically duplicate the code we have, except we change the route, the string of what we're trying to match. So basically in our app.js file, we'll have two questions, which are pseudocode. The first one is, did the client request slash? That's what we already have. If they did, respond with welcome to the home page. Then we'll also have did the client request slash joke? And if they did, respond with knock knock. So only one of these is going to run every request because you can't send a request that is simultaneously to slash and slash joke. So we get one response depending on what we request. So without further ado, this is all we have to do. I apologize, it's kind of long because the joke is long. Otherwise, the code is pretty short. App.get slash joke function, request response. And then in here, we just have a joke variable equal to our dumb joke. And then we're doing a res.send joke. So if we compare that over here to our existing route, it's very, very similar. So we'll get used to typing app.get. Yeah, that was just terrible, but you do it a lot. App.get, and then we'll do joke. And that's just something I picked arbitrarily, right, to have a joke route. When we're actually working with our app, we'll talk about the routes we need for join us. But for now, we're working with slash joke. Request and response. Once again, we can call these whatever we want, but rec and res is pretty standard. Then in here, I'm just going to copy the joke. I don't want to make you watch me type that. All right, so we have that. And what we can do is the same thing we did earlier, console.log requested the joke route. Quick quiz. What will happen when I run node app.js? Well, when I just run it, nothing will happen unless we had an error. But what will happen when I make a request to slash joke? And the easiest way to do that is if I do preview running application. And if I change this to slash joke here, or I could go over here and do it in a separate window. But if I do slash joke and I hit enter, what do you think will happen? It just keeps spinning and spinning. We get requested the joke route, which is what we wanted. We console.logged. That means this route is being hit, and we're running this code. But now over here, it's still spinning and spinning. And eventually it will stop, and it will give us an error message saying, cannot get slash joke. Basically, that's saying, I tried, we waited, but there was no response from this server. So the server received it, we did something, but we never sent anything back because we're missing res.send. So very simple remedy. We can have this console.log if we want it, but it served its purpose. Now let's do a res.send, and all we want to send is the joke. Okay, so I'm going to stop this one. Well, actually, I'll just restart the server, and that will kill it immediately. Now I'll do node app.js again, make this bigger. If I can get it, go to slash joke, and I hit enter. And now I get this hilarious joke we've never heard before. What do you call a dog that does magic tricks? A labracadabrador. It's pretty good. Pretty good, whoever came up with that one. And that's it. We have our two routes now. So we could toggle between them. Whoa, eBay. I don't know where that came from. Here we go. So I've got the home route, slash the root route, or slash joke. And that's it. So really the point here is just to show you can have two routes, and usually applications have a ton of routes, 10, 20, depending on how complex the application is. Something like Cloud9 or Udemy might have 50 or 100 different things. Well, 100's extreme, but there's a lot of different routes. To wrap up, let's add one last route. This one is a little different. What it will do is return a random number, randomly generated. So it's not going to be hard-coded in like you've reached the home page, or what do you call it? A dog that does magic tricks, a labracadabrador, haha, very funny joke. Rather than that, it's going to be dynamically generated. But everything else is the same. So it's app.get slash, and we're doing random num or number, either one. I did num in the notes, comma, function, request, and response again. So whatever's in here will only be executed whenever someone requests slash random num. So we'll do our app.send, res.send. And let's just start by just hard coding a number like 7. I'll do it as a string just to be safe. If we restart the server now, go over here, joke still works, home still works, but now we have random underscore num, and I get the number 7. So now all that's left is to generate a random number. And the way we do it in JavaScript is kind of obnoxious. It's much easier in other languages. So there is a math.random. And what this will do, I'll actually just show you right now. If I copy it over, I'm going to stop the server. I'm going to open just regular Node, which is not something I've shown you, but Node has, just like MySQL has a CLI where we can type things and get a response immediately. You can do 1 + 1 and get 2. Node has the same thing. If you just type Node without a file name, then it opens up a Node shell. So if I do math.random and I don't capitalize that R, now I do math.random, notice that it gives me a random number between 0 and 1. It's really annoying that it does it this way, in my opinion. So if we want, let's say, something between 1 and 10, there's a couple of steps involved. We need to generate our math.random. We need to multiply it by 10, so we'll start with that. Okay, so now we're getting 1.7, 7.4, 8.6. Then what we need to do is get rid of that decimal. So you can either round. What's more standard is to do a math.floor. So what that will do is just chop off the decimals. So we end up with 8, 9, 8, 2. But then we have a problem, which is we never actually hit 10. We're doing a number between 0 and 9. Which you'll just have to trust me, that's how it works, but you can see we have 0 here. And it's because when we did our original math.random, this is a number between 0 and 1, not including 1. So up to 0.99999. So all we want to do is then shift it by 1. So it's kind of a lot of work to generate a random number between 1 and 10. But now we've got it. Just to prove, okay, there's a 10, we're in the clear. So now we'll just make that a variable. We'll just call it x maybe. Equals, well, maybe num is a better name, make it a little clearer. And then we'll just send it back. We'll say and I think I said lucky number is plus num. And that will just concatenate it in there. Let's try it. So to get out of Node, we just do Control-C twice. Now we actually execute our app.js. Now if I go to random num, it says my lucky number is 3. Now it's 10, now it's 8, 8 again, 4. You get the picture. And of course, we still have our home route and our refreshingly adorable and hilarious Labracadabrador joke. Okay, we're done here. Moving on in our next video to actually integrating MySQL with this web app. Big step. Woo, okay. Very enthusiastic now. We're actually getting to the web app and writing code in this section, in this video. We installed Express now. We're ready to go. But we need to discuss what we're going to make with our first, most basic pass at a web app. So here's a nice little, hopefully you think it's nice, a little diagram I made of a typical request and response cycle that we'll be working with in Express. So here's a computer. Let's say it's Blues, my cats. And then there's our Express app that we'll be creating, which is Node, JavaScript. And Blue types in the name of our app. Let's just say it's www.app.com. She hits enter. A request is sent to our Express app saying, hey, I would like the slash page. And slash right here is referring to the URL that we're asking for, the path after. So if you notice, I'm on webdev.slides.com. This is basically like our entire Express app, what we'll be creating. And then individual pages we ask for by varying what comes after the slash. So if you take a look, if you never noticed that before, the path that comes after a slash on a web page, that is usually what dictates what content you see. So when we don't ask for anything, if I just go to webdev.slides.com, that's going to be the home page. And the way that we would kind of write that is the path is slash, just / nothing. Okay, so hi there, I'd like the home page, please. And then the Express app has to figure out what to do. Says, sure, here you go. And sends back our super simple hello from our web app. That's it. It just is a one line of text that says hello from our web app, no colors, no animations, nothing like that. And there's no logic involved to start. Every time Blue goes to this page, she gets hello from our web app. Now, what we're working towards is creating dynamic pages that will vary, that will say, hey, we have 518 users, or here's a list of all of our users in the database, or something like that, that varies depending on when the user asks for it, who the user is. There's a whole bunch of different conditions. So that's the flow we're trying to get. We send a request asking for a particular thing, and our Express app has to figure out, one, how to handle that. How does our Express app know what we're asking for? Second of all, how does it respond? So it's these two arrows that are really the important part, the request and the response. So let's get started. Here's what the code looks like. So there's a little bit here that we haven't seen any of this. We've seen requiring. So all we're doing is importing Express and saving it into an Express variable. Then we're doing this weird thing that we haven't seen, where we're actually executing the entire Express package that we just imported. And we're saving that to another variable called app. Basically, these are the first two steps of any Express application. Copy and paste them every time. I mean, they're not very long, so you could just type it, but you can treat them as just cookie cutter every time. Then, every time we refer to this app, like we have here, app.get and app.listen, both of those are referring to this app. So anytime we work with Express, it's going to be a lot of app.something, app.get, all these other things, which on the documentation, you can see over here, we have all these app.delete, app.enable, app.get, app.listen, app.param, all these different things. They all start with app. Of course, if we name this variable something different, Apple, then this would be apple.get and apple.listen. So far, this doesn't do anything. These are just two lines to require stuff. The magic is really here and here. The first thing is what's known as a route. This is the bread and butter of Express, pretty much every web framework. What it does is this code inside is only triggered whenever an incoming request is made to this path. So we're basically defining the code that runs when a user asks for a home page, where the path is nothing. It's just slash. And what are we going to do? Well, we are going to send, this is a special method from Express, hello from our web app. And res is coming from here. There's a lot to take in, I know. Res is the response object. Request is the incoming request. So every route, there is a callback. Just like when we were working with MySQL, a callback is code that runs after something happens or at a later date. So this code only runs whenever a request is hit to slash. So eventually we'll have code where we have 5 or 6 routes, different web pages. We want to run different code depending on the web page that's being asked for. So this is how we do it. This is basically saying if a request comes in for slash, run this code. We could have another one down here that says if a request comes in for slash log out or slash log in, then do something else. Show the login page. So that's the first bit. Then every route has a function, a callback, with 2 arguments, a request and a response. Request, again, is the incoming request. So if we wanted information from the incoming request from the user, which we'll be working with later, when a user types their email into the form to sign on to our waitlist, that information is sent to us. And so we'll need to work with the request coming from the user. It's this arrow. That will contain the information. Hello, I'd like to add my email, blue@gmail.com, to your database. And so then with the request, we'd be able to pull it out of there. The response is what we're sending back. It's this arrow going that way. And so that's why res.send, hello from our web app, will send this response. Of course, you don't have to name it rec and res. You could call this request and response. You could call it R1 and R2, apple and orange. All that matters is that you refer to it the same. And then we have this second component. And this is also kind of cookie cutter. You'll have this in every app, app.listen. And all that this does is starts a server. So this starts the server going. We have to tell it what port, which on Cloud9 will always be using 8080. And then if we want, we can give it a callback function. And this is just a line of code that will run once we start our server. So it will just say in our terminal, hey, your app's listening on port 8080. You don't have to have this. So let's go over to Cloud9. And the first thing I'm going to do is make a new file. So inside of join us, new file, and it's going to be app.js. And I'm going to just start by requiring Express, just like we saw. Then I'm going to do var app equals Express which is referring to this, executed as a function. So we have app there. Let's just see if it works. Nothing will happen. We may get an error if we didn't install Express, but we did, so everything's good. Then let's start actually at the bottom with our app.listen. And we tell it the port, which is, if you're not familiar with the idea of ports, think of it as the entry or exit point on a computer. You can have 20 or 50, 100 different ports for different things going on at the same time. You may have had to work with ports if you ever had to like mess with a firewall that was blocking something you didn't want it to block, or if you work at an office where they don't allow you to go to certain websites. That's running on a certain port. Anyways, app.listen 8080, and we could just leave it at that like this. But if we do that and I start it up, notice my cursor has gone to the same thing that happened with the MySQL connection when we didn't end the connection. It's just hanging. And that's because I started this server. It's listening on port 8080 to see any incoming requests, but we're not doing anything. And it's also just not very, it's not a great experience to just see a blank cursor there. So we can just add this blank callback, and it will just console.log server running on 8080. And it's just a nice message for us developers to see. So now if I do it, you can see, of course, that we get console.log server running on 8080. And that's just because this code runs, whatever we put in here will run only once the server starts. So that's the first thing. But now we have the task of actually writing the code. So we have our server, it's going, but we can't actually reach it. We can't do anything with it. I don't have anything to respond with. So actually what I just said is kind of a lie. We can reach it. We could request it, but nothing would ever come back. And actually, if I try and preview it right now, so to do that, we can click on preview running application. This is hitting this server, but we're not getting any response. So I'm going to just leave it here for now. We'll come back to that. We'll know that our app is working if we get a response here. To do that, we just have to do our app.get, and then the URL or the path, which is / function request response. And then in here, we put some code. So we could start with just a console.log. Someone requested us, just like that. What do you think will happen? First thing I have to do is restart the server. Anytime you change this code in here, the server was already running. We need to save the file and restart. But now, if I try and request /, so I'll just hit enter here. Notice what happens. It says someone requested us because this code ran. But over here, we still don't see anything. So console.log is only printing to the console here, the terminal. So now what I'm going to do is open a new tab and put this in that tab so that we have our app and then our terminal down here. And I'm going to close this one just to make more space. It's the same thing. Notice though, every time I hit enter, I get someone requested us. But if I tried to go to /logout or something that doesn't exist, I don't get someone requested us because this code is only happening, it's only firing off when we're requesting /. And you might be wondering about the get part. If you're not familiar with HTTP requests, there's a couple of different types, different verbs. Get and post are what we'll be working with. A get request, though, think of it as just asking to see information. You're not sending any data with it. So when we are asking for our homepage of join us, we're just trying to see information. It's a get request. But when we are trying to join, we are sending an email, and that is going to be a post request. We'll get there in a little bit. I know it's a lot of stuff and overwhelming if you've never done web development, so hopefully you understand this is not a web dev course, but there are some great ones out there. And I highly recommend, if you're curious and you are enjoying this part, that you continue down that path. Okay, enough of that. So rather than just console.log, there's this other thing we can do, which is response.send. And then we can put any string in here, like you've reached the home page. I'm sorry about that siren. It's like 100 degrees in San Francisco today. Oh, that's a lie. It's 90 degrees. I have to have the window open. Okay. Hopefully it's not too loud. Now we need to restart the server. This time, we now have some different code. Same thing. If we hit / on this app that is running, on 8080, which in Cloud9, this is our URL. Yours will be different. You have a unique URL you need to access, but this is where your app will be running. Just like when we first installed Node and I showed you that chat app, it's the same idea. This is where your app runs by default. So now all we need to do is hit that page, but we need to ask for / rather than /logout. If I do /logout again, I get nothing. But if I just do / or nothing, we get our message. You've reached the home page. And that is our most basic web app. Of course, you could change this text. Something that people ask a lot is, can you have 2 res.sends? And the answer is no. You can only have 1. Every route is going to respond with one thing. But the real answer is that you're usually not going to use res.send. You'll instead be responding with files. So we'll have a file of HTML to respond with our nice formatted page with style and fonts and colors. For now, this is the very basics. So we'll stop here. You can feel free to move on to the next video where we add more routes. But at the very end, I'll take some time to review if anyone is curious or anyone feels like you need more review of how this works. So we started by requiring Express, which is the library or the framework we installed. Then we execute it and save it to our app variable. And really, there's a lot of magic happening there. That's what a framework does. It takes care of stuff in the background. But now what we've done is, first things first, we started up our server, app.listen 8080. And every time we do that, our server starts running. And basically, that is this block right here, represented by this block. And it's just sitting here listening. It's a patient server. Nobody might talk to it for years or maybe ever. But as soon as someone sends a request, and in our case, the request goes to this URL, Node and MySQL, learnwithcolt.c9users.io. Yours will be different, but this is where I make a request to, and that corresponds to our server we started down here. So there's an invisible connection here that's kind of taken care of for us by Cloud9 or by any computer. Although your URL would be different if you weren't using Cloud9, of course. But whatever we're running here, our server, it's waiting and listening for a request coming in. Then we write code that differentiates between something like log out, or let's do log in. We don't have any code expecting login. So that's why we get an error. It says cannot get login. It's basically our server saying, I don't know what you're talking about. All that our app knows about is /. That's the only thing it will respond with. Oh, I know that. Let me give you that. It's you've reached the homepage. Otherwise, we get cannot get whatever we do. But we do have this one case where it works, the homepage. And again, the typical terminology for this is the root route, the home, the root, the empty route, basically /. So app.get /, this code runs, and all this code does is it responds with you've reached the home page. One thing that's interesting to take a look at, there's a lot here, but if I do a console.log request, this will contain all the information from the incoming request, from this arrow. There's going to be a lot of stuff in there. So if we take a look, try it again, and I make a request, I'll refresh it by clicking. Over here, we got printed out this giant thing. This is all the information contained in that request. So all of this is put together by Express. It's handled for us. Let's see if there's anything interesting to take a look at. Basically, I can't find anything terribly interesting or that would be very useful without me having to explain a ton of other stuff. But this contains all the information. You only get 1 or 2 things usually that you care about in here. This is all behind the scenes stuff that it works with. With that said, when we make our request that is sending our email, when we type it into a form and hit submit, that email will be contained in a request somewhere, and we'll need to pull it out, which we'll get there at some point. All right, next up, we're continuing on with this, but we're going to add a couple other routes. Okay, so we saw Express, or I introduced it. Now let's get down to work, let's install it, and let's make our first simple web app. And I don't want to get your hopes up too much. This web app is going to be very, very bare bones. Basically, will be a website. You hit enter, or you go to the URL, and we just get a single message back saying whatever we want, congrats or hello or something. So nice and simple. But the difference between doing that and then responding with I don't know, a big, beautiful website with images and big text and animations isn't that much as far as the code we have to write on the back end, which is what we're focusing on now. It's the same idea. You respond with some content. What you respond with, well, that's a different story. Okay, so don't run this. It's a big red letter say, but to install Express, like we've installed Faker, or we installed the MySQL package, you just run npm install and then the name of the package. However, rather than doing this, this will work fine. It will install. I'm going to show you another way of using npm that's a little bit nicer, a better practice. And it involves running this first command. What does this do? npm init creates what's known as a package.json file. So if that doesn't make any sense to you, don't worry. Basically, when we make a new project, let's say we're working on a big node project with like a web app, and our web app might have 20 packages involved. So we're only working with a couple right now, but it could have 20 involved. Rather than just installing them individually and leaving no record of what's been installed and what version's been installed, what we can do is create a package.json file, and it acts as like a log file of everything we install. So that if I send my code to someone else across the world, or I post it on GitHub, for example, all that the person has to do to run it is take that package.json and then run a single command, npm install, which will then go find the package.json and install every necessary package. So let me show you an example. This is actually the GitHub repo for Express.js, the framework we're about to install, which is itself, it's a node package, and there's a package.json file in it. And if you look, there's this giant dependencies section. These are all different packages that Express needs. So when we install Express, it goes and installs all of these things as well. So we don't have to do it, right? If this package.json wasn't here, we would have to manually install array flatten and content disposition and cookie. Thankfully, we don't even have to worry about what these do, let alone the fact that they exist. So that's the point of a package.json. It's a way of storing not only the packages that are necessary, but then the version. Because this version of Express might be totally broken if we used 0.6, if that exists, or escape HTML 0.0.3 instead of 1.0.3. So that's all we'll say about it for now. But to actually create the package.json, what I'm going to do is first make a brand new folder, just so that we're working in a different folder, and I'm going to just call this one Join Us. And that's where we'll be building the application. So everything else we've done up until now hasn't actually been building the app. So what I'll do is now cd into Join Us with the terminal down here. And it should be empty if I type ls. We're now in this directory, there's nothing there. So we're going to run this npm init command. And this will just generate a new package.json. However, it's interactive, so it's going to ask us for a name. And what you can do is just hit enter if you want it to just accept what its the default value is. But if I hit enter now, I'll get a message saying, sorry, name can no longer contain capital letters. So let's do join us underscore. Version, we'll say it's 1.0 of our app, that's fine. Description, we can leave it blank for now. Entry point, I like to change to app.js. This is just the name of the file that we're writing our app in, or the main file of our app. We could have 20 files, but what's the start point? Index is fine too, but I'm going to do app. Then I'm just going to hit enter until we're done. You could put author in there as well, and a license. Then you can see the basic text it generates for us, the JSON, which is the data format. And I'll hit enter. Now I have a package.json file up here, and it's ready for us to install things. So now what I'm going to do is run npm install express, but not on its own. I'm going to add -- save, and that will save a record of our install into our package.json. So right now it's not here, but if I do npm install express -- save like that, takes a moment, you'll see, first of all, we have our node modules now inside of join us. So we installed it in this directory, which is good. Then in our package.json, we now have express saying 4.15.2 is our version. And while we're here, why not also just reinstall npm install two other packages we need for our app. The first one is Faker, and then the second one is MySQL. You can just separate them by spaces and add -- save. and it will just add both of them in here too. Not a deal breaker. We already have installed them on this machine, but it's nice to have them in this directory too, and also have records of them in our package.json. So now if I wanted to upload this to GitHub or something and share this with someone, I wouldn't have to, send them the node modules folder and send them the actual Express directory and Faker and MySQL. I could ignore that because this is the largest part of our directory structure right now. This, I don't know how many megabytes it is, but it's a lot more than this single file or our single app.js file. So it's better to just have our friends or other developers download what they need remotely. So I just send them this recipe that says, oh, by the way, you need these 3 things. Here's my code plus the package.json. Then they go take package.json and they install these things. And the way that you do that, by the way, is running npm install, and you don't add anything afterwards. It will try and install everything in the nearest package.json. All right, so we have Express installed. We don't have an app yet, not even an app.js file, but we have the structure that we need to create the app. Hey, welcome back. Very high energy because we're moving on to a very exciting portion of the course. We've now seen how to take a database in MySQL, everything we know, and combine it with a node file, a single file that doesn't do, it depends on your impression of it. It doesn't do a whole lot, it just inserts, but it inserts 500 things, which is pretty cool, and they're all randomly generated. But that's not an application. That's still useful for our application. We'll be able to use that. Just to recap, the whole reason we're doing that is so that when we start up our application, we have some data in there. We have something to work with. Rather than totally empty database or something that has 2 users, we have 500 realistic, randomly generated emails and created at dates. Okay, so we've done that. We have that. Now we're moving on to the web application portion. So remember, this is Join Us, our mailing app or waitlist app, where there's a nice page it looks styled, it's nice. It says Join Us in big letters. It says how many users have currently joined. And there's also a guarantee 100%. It's not a cult. And then there's a form at the bottom where you can actually enter your email to join the list. So we have to get there. We're going to start with the basics of a web app. So just like we had to start with the basics of Node, we're now starting with the basics of building web applications. Okay, that brings us to something called Express. So if you've taken my other course, or if you're familiar with Node and you've used it in any web development capacity, you've probably come across the framework Express. It's a web development framework. It helps us make applications faster. So if you're not familiar with frameworks, in 10 seconds, what they are tools, libraries, that are a bit more complex, a bit more controlling of how you write your code. They dictate things for you. You play by their rules, but they help you make things faster. So a web development framework helps you make websites faster. There are iOS or game development frameworks that help you make games faster. So they kind of limit your freedom a bit, but they empower you because they speed you up and they let you focus on the things that matter. So with all that said, Express is very simple, a lightweight framework. What it allows us to do is once we install it and include it in a file, we can very quickly make a web application. So something like Faker is a package that allows us to quickly get random data, a very small kind of feature it's useful, but it's a small thing. Express is a package that when you use it and install it, it does a lot. It sets up a server for you. It listens for incoming requests. It figures out how to respond to requests. It handles HTML and CSS and responding with that. It figures out how to parse a response body. All these things we'll go into, but it does a lot. So let's take a look very quickly at the documentation, expressjs.com, a fast, unopinionated, minimalist web framework for Node.js. As you can see, you can just install it. npm install express. We'll talk about -- save in just a second. And you can read more about it here. Basically, it provides a robust set of features for web applications. It's lightweight. So what that means, if I go over here to Node.js Frameworks, it's a site that I found, it has a list of some of the most popular Node frameworks. There are a ton of them out there because people love using frameworks for good reason. They help you make things faster. There's 2 categories that this person has categorized them into, Sinatra-like and Rails-like. Basically, this comes from Ruby. These are 2 Ruby frameworks, Sinatra and Rails. Rails, you might have heard of. It's a bigger framework, very popular in Ruby, but it controls everything. It's very strict. Sinatra is much lighter weight, meaning that you have more freedom to make decisions. It's less opinionated, which means that you can configure things how you want. But also, the advantage of something like Rails is that you don't have to make decisions. For example, how to structure your files. Where do I put my CSS files? In Rails, you don't have a choice. In Sinatra, you have to decide. So with that said, there are all these frameworks for Node. Express is the top one here that we're going to use, but there are other ones. There's Sails and Getty are two that I've used. Koa, okay, I don't know if it's pronounced Koa or KOA, is one that's becoming popular now. A lot of people are using too. So anyways, I'm just trying to point out here that there are a bunch of frameworks. Just like when I said we could have used any language to talk to MySQL, we could use any Node framework to make a web app. We're happening to use Express. Okay, so the first thing I recommend here is to look at the documentation for Express. If you're curious, if you haven't taken a course in it, you're not familiar with it, or you have never worked with a web framework, the documentation is pretty straightforward. If you click on Getting Started, you don't have to go through all of it. But if we actually go, let's do like a hello world. Here's a simple app that we'll be making in just a moment. But it has a nice kind of walkthrough of using Express, how you write certain things, what the syntax is, and then there's a guide that's much more in depth, and then there's a reference. When you click on API reference, make sure you're doing 4.x, the most recent, and this is sort of like think of the MySQL docs. There's all these methods that we see over here, and you can read about them over here. So we'll be referring back to these docs as we go through the course, and for now, that's where we'll leave off. All I wanted to do in this video was introduce Express, tell you that it's a Node framework, show you the website, the documentation. Then in the next video, we're going to install it and create our own first application. First web app. All right, we made it. This is the section that a lot of you probably have been waiting for. It's where we connect MySQL not to just a random Node file, but to a web application, which is really just a random Node file that has some other code in it we haven't seen yet. But that's what we'll see in this section. So we're going to build a very simple app that serves as sort of a mailing list for a startup / cult, C-U-L-T, not C-O-L-T, a cult. It's very hard to say. But that's what we're going to build, a mailing list application that, we could collect emails before we launch a product or something, or collect emails before the world ends or whatever we're worrying about. So we're going to see how to do that in this section. It's going to be mainly a code along. So it's going to function really, I'm going to show you something, then you'll do it yourself, and I'll show you something else, and you'll do it. There's not going to be, a ton of new content as far as MySQL is concerned, really none. It's really all the auxiliary stuff that goes into a web app. So if you don't know anything about web development, I should preface this by saying there's going to be a lot of stuff here. And this is one section, right? This could be a whole course on web development. In fact, some people have built courses on web development. This is not a course on web dev. So it's an hour or so of content, not 40 hours of content. So don't get overwhelmed. Just follow along and build it. If you are someone who knows web development, some of this may seem a little bit slow for you. For example, when I'm talking about HTML and CSS, feel free to skip whenever you want, but in particular, those sections. So that's pretty much all I have to say here. Congratulations on making it to this point. Very exciting, hopefully. We're going to see how to make an app. Blue's very jazzed about it, aren't you, Blue? Blue. That's about the most excited she ever gets. I miss dogs. Alrighty, welcome back. So this is a new section, not just to you, obviously it's new if you're watching this, but new to the course itself. I added this, it's basically a month right now since I published the course, and I'm adding it because a lot of people have been requesting this topic. There's been a bunch of comments and people have been asking about this, so I decided to add it. And that topic is database triggers. So if you're worried about it, if it seems super advanced, it's actually much simpler than learning some of the earlier topics. Things like joins are much more complicated conceptually. So this is nice and easy. There's just a little bit of new syntax we need to talk about. But before we get there, let's talk about what the heck it is. What are database triggers? They're just SQL statements, bits of code, that are automatically run when something happens, when an event triggers them. So when a specific table is changed. So this is actually really, really useful in certain situations. So I should start off by saying this is not something that you'll be using all the time. Even in a big, if you work at a big company with a big production database, you're not going to have a bunch of triggers. You're not going to be writing this type of code often. So it's not central to using MySQL in any way, but it's a nice thing to know how to do. And when you do need it, it's really nice to have. So again, it's basically SQL code that will automatically run when they're triggered by certain events. So here's the syntax. It's not going to make a bunch of sense just looking at it like this, but here's the rough pattern. So there's this new bit of code, create trigger, and then we provide a name. And the name is not all that important. It's really for your purposes for referring back to it, or if you're trying to remove that trigger later on. But you, as always, you want to give it something meaningful. But then we have three really important components: the trigger time, the trigger event, on, and then the table name. And then the syntax for each row, begin and end. So we'll talk about the syntax a bunch more. We'll write some code, but let's dive into these three things: trigger time, trigger event, and table name. Hopefully it will make a bit more sense. So as I said, these triggers run code when a particular event happens, when a table is changed. And these three components are very important to that. So the first one is the trigger time. And there's only two choices: before and after. So do you want this code to run before something happens? Let's say an insert. Do you want this code that you have to run before you insert or after an insert? Then moving on, we have trigger event. There are three choices here. So three changes that can trigger this code to run. We have an insert, an update, and a delete. So you can run some code right before something is inserted into a specific table, or you can run code right after something is deleted. And I'll show both of those examples actually, as well as update. And then table name has basically infinite choices. It's just the name of a table that exists in your database. So we could run some code before you insert into photos, or immediately after updating the users table. So whenever that happens, when any single item in the users table is updated, whatever code that we have between the begin and end, and there's a lot of new syntax, I know, so don't panic, we're going to get to that in just a bit, but whatever code you have there will automatically be executed right after a successful update on any item in the users table. And we could do the same thing for delete or insert. So the last thing I'll talk about in this quick intro video is what kind of things would you do with this? And there's really a couple of categories. The first has to do with validating data. And this is a bit controversial, in my opinion as well. I'm not just saying other people think it is, but I actually don't think this is the best use of triggers. But what you could do is enforce specific things on your data. For instance, you don't want to let somebody sign up for your application unless they have an age that's greater than 18. You can actually write a trigger in MySQL to prevent that creation or that insert from happening if the age is less than 18. Now, the reason I say that it might not be the best use is that you could also do that in your application code. So if you have a web app, an iOS app, a computer app, it's much easier to write code that just says, is this age less than 18? Well, then don't even try to insert it into the database. But because this is a course on MySQL, I am going to show you how to do those validations. In fact, it's going to be the first thing we do. And the way that that works is you run code before inserting into a table. So we would have run this code that checks if age is less than 18 right before inserting into the users table. So we'll do that. But then the second category has to do with manipulating, creating, deleting other tables relative to your trigger table. So the example that I'll give that we're going to do, if we have our Instagram data where you can follow, or any social network really, where you can follow people, you have friendships, it might be useful to actually know when somebody unfollows someone. If we're a company, we want that data. It could be relevant. We could sell it, or it would help us understand when certain ad campaigns backfired maybe, and I started unfollowing, or our users started unfollowing particular accounts. Well, currently, there's no way of keeping track of that. If a user unfollows someone, if they delete their following relationship, essentially, it's gone. What we could do, though, is use a trigger to say, okay, right after a follow is deleted, we're going to create some new row. So you could think of it as sort of logging your history, which is a common use for triggers. So that's just one example of two different ways of using triggers. We're actually going to see three different examples in this section, but those are the two broad categories. So validating your data, and then the second one is manipulating other tables based off of an initial table triggering that action. So I think it will make a lot more sense once we dive into the code. So in the next video, we're going to go ahead and create our very first trigger. Okay, welcome back. In this video, we're going to create our very first trigger. And as a heads up, there's a lot of new code, a lot of syntax. The way that this is going to work is that we're going to run the code first, and then we'll ask questions later, which is maybe not always the best approach, but I think here it will help just illustrate how things work, kind of the overall goal, because you can get lost in the woods. Is that the expression? Whatever. You'll get lost potentially if you focus on these new things like this here, all this stuff here that we've never seen before. And I don't want you to get hung up on that. But we will address it in future videos, the next 3 videos after this, in fact. So in this one, we're just going to get this running and see that it works. And what it is, it's a very simple validation that basically we have a users table with any data, let's say name and age, username and age. And all that we want to do is prevent new users from being created if their age is less than 18. So it's pretty straightforward, the idea behind it. Like I said in the previous video, it typically would be better to actually do this on the client side of your application rather than waiting for the insert statement to get to, or rather than initiating a statement, sending some code to your database, having the database try and insert it, and then realizing, hey, age is less than 18, then sending an error back to the client side. That can take time. It's much better to just say on the client side, let's say of a web app, have a validation on the form that is going to check, is age less than 18 on this form? Well, then don't let the user submit the button, or don't let them click the button, or display an error message or something like that, rather than bothering with all this database stuff. But it's important to know that you can do this. So I'm going to show it to you, and it's a nice, simple example. So a couple things. I'm in a new folder here, just called triggers. I'm going to make a new database as well. And I guess this is a good time, as good a time as any, to let you know that I have seriously injured my wrist on one hand. So I'm typing one-handed. I'll try and edit around it. Hopefully it's not too noticeable. So we've got create database, and I'm just going to call this one trigger demo. Oh man. Okay, here we go. Then we're going to use that. All right. Now I'm going to make a new file just while I'm here, and I'll just call this users.sql. And we're going to make a simple table, create table, very, very simple, users. And like I said, it's only going to have, let's go with username, which will be a varchar. And then we'll also have age, which is an int. And that's it. Okay, so we can go ahead and run that just to validate that or to check that it works. So we'll do source users.sql. I ran this in the same directory. Okay, we should be able to do show tables, and I should be able to insert a user. Let's do insert into users, and we'll do username, comma age. Should all be boring review at this point. We'll go with Bobby, and age is, let's go with 23. Okay, there we go. And as always, select star from users, just verifying that everything works. All right, pretty boring stuff. Now we're going to go ahead and create this trigger. And what this trigger is going to do is right before a piece of data is inserted into users, right before a new row is created, we're going to say, hang on, there's a trigger that's just been triggered. And it's going to check if this new user row, if the age is less than 18. And if it is, then we're going to throw an error. We're not going to let it happen. Otherwise, proceed normally and insert the user. So the syntax, I've already typed it up here. You can just copy this if you'd like. It's going to be easier. Well, like I said, we'll go over the ins and outs of it as we go through this section. But to start, we'll just copy it. And what I'll do is make a new file. You don't have to. You could just add it down here and just rerun this whole file. But then you've already created the users table, and so you would have to recreate it and drop it and then recreate it. Anyway, it doesn't really matter. I'm going to make a separate file. I think it's good to keep your triggers separate. So I'm just going to call this users trigger.sql. Okay, and then I'm just going to paste it in and hit save. And then I'm just going to source this file just like any other SQL file that we've run. It's just a little different than what we've done before. This is sort of like meta SQL, where we're not actually interacting with the database immediately. We're not creating tables. We're not inserting things. We're creating restrictions or triggers on another table. Okay, so I'm going to source it. I called it users trigger.sql. Oh, actually, before that, let me just verify that you can create a user who is less than 18. So let's say Sally is 16. And that works just fine. They're both in there. But now when we source our users underscore trigger.sql, we get this silly error, which is my fault. And rather than editing around this, I'm actually going to leave it. It's somewhat educational. I have a table called people that it's expecting. Before insert on people, well, there is no people table in this database. It is a users table. So let's recreate that. Okay, so now I do that, and we get this message that, like we get every other time something works, query OK. Now let's see what happens. So let's start off with something we know works, like let's do Sue, who is 54. That should work, and it does work. But now let's do, man, this is the hardest part. Let's go with Yang, who is 14, less than 18. And we get our message, error. We'll talk about this, 1644, 45,000, all that fun stuff. Must be an adult. And it's not just an error. If we actually go select all our users, Yang doesn't get inserted. So it's not just like an error that gets thrown out just as a FYI, but it also prevents things from actually being inserted. So that's the basics. We've got it working. In the next video, I'm going to break down some of the new pieces of code, in particular, what the heck this is here and here and here. Also, what this new thing is, new.age, and most importantly, what is signal, SQL state, 45,000, message text, all this stuff. All right, so we ran the code first. Now we're asking the questions. So going back to the code here, there's a couple of things I want to point out. We'll come back to the delimiter stuff at the beginning and end, but I want to focus first on the basic syntax. So create trigger, that's standard. We give it a name. I called it must be adult. You can call it whatever you want. It doesn't actually have any impact. Again, it's really a label so that if you do want to delete this trigger later on, you have a name to call it by so that we can delete must be adult, but give it something meaningful. Then we have the important stuff. So this is the meat of the trigger. We have our trigger time, the trigger event, and the trigger table. So this is the users table. That's the simplest one to start with. We want to run this code here right before something is inserted into the users table. Now, if we had said after, it wouldn't really do much because it wouldn't prevent a user from being inserted if their age is under 18. It would still check, and it would still give you an error if age was less than 18, but it still would insert it because it would be running afterwards. So it's not really a validation. So because of that, we definitely want to have before. But I will be showing you where you can use after in another example in just a couple of videos. But in this case, before insert, so it will run immediately before anything is inserted into the users table. Then we have for each row, that's just default syntax, begin and end. Notice a semicolon here. We'll come back to that. And whatever's in between begin and end is the actual code. This is SQL code that runs every time right before something is inserted into users. So let's start off by talking about this if new.age less than 18. So first of all, we have this if syntax where we have if, then, and then end if, which we've seen before. But more importantly, we have new.age. And new in this case is just a placeholder. It's referring to the data that is attempting to be inserted. It's referring to the new user that's going to be inserted into the table. So if new.age is less than 18, do this. Otherwise, don't do anything. There's also an old, OLD, that goes along with new that we'll see later on. Once we've deleted something, we want to have access to the data that was deleted, we can use old dot whatever. So new.age less than 18. New is a placeholder for whatever user is being inserted. Then we move on to the slightly trickier thing. What the heck is this signal SQL state 45,000 set message text equals must be an adult? So this second part is probably more self-explanatory. Set message text must be an adult. We saw that message text here, must be an adult. But this SQL state thing is kind of confusing. So according to the MySQL docs, there are 3 components to a MySQL error. There's a numeric error code. 1146 is a common one. And these are actually MySQL specific error codes. But then there's these other things called SQL states, and that's what we care more about in this situation. It's a 5-character value. It's not just numeric. It can have letters. And they're taken blah, 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 blah. This is from the docs, by the way, if you want to read more about it. But they're more standardized across SQL databases. So it's not just MySQL specific. This signal state code can be recognized essentially across different databases. And then along with that, there's always a message string, a textual description of the error. So that's important for humans, for us to recognize what's happening. But for our code to recognize what's going on, it's much easier to work with these numeric values or these SQL state values. Those are easier to recognize. You can write code that says, hey, if we get an error equal to 42SO2, then do this. Rather than saying, if we get an error that says exactly must be a number, or must be greater than 18, there's sort of a lot of wiggle room there depending on how it was implemented. But these numbers, these hard-coded values that never change, are much easier to check against. And as a side note, on the MySQL docs, there's this page, server error codes and messages. If you scroll down, you'll see there are tons of these messages or there's these errors and accompanying messages. Let's just pick one. Let's say, here's one here. Error. So the MySQL error code is 1005. The SQL state is HY000. And the message is can't create table. And then inside of here, it will put the name of the table you try and create. So this would happen if you tried to create a table for some reason that you couldn't. I'm trying to think of actually how exactly this would happen. It says a foreign key constraint, potentially it doesn't matter that much, but however you get this error, it will show you the error code, the SQL state code, and the message. And in fact, if we go try this, cause an error on your own, feel free to do whatever you want to cause an error, but here's one we could do. Select star from this table that we know doesn't exist, just gibberish. If we try and do that, go over here, we get an error. So it says error, and then we have 1146. So that error code is the MySQL specific code. Then we have the SQL state, 42SO2, and then we have this text, table, trigger demo dot blah, 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 doesn't exist. So this is the message, this is the SQL state, and this is the code. What we care about is the SQL state and then the message. And if we go over to the docs again and we try and find that code, so we had the SQL state was 42SO2. You can see that it shows up a couple times. There's an unknown table, message unknown table, but there's also bad table. And is there another one? Yes, table doesn't exist, error no such table. So those all use the same SQL state, but they use a different MySQL error. There we go. So 1051 versus 1109. This is really getting into stuff that doesn't matter that much to us. And the reason that it doesn't matter to us is that we're going to use one and only one SQL state, which is 45,000. So 45,000 is sort of like a wildcard state that is generic, and it represents an unhandled user-defined exception. So it's kind of just left out there for us to use it, for developers to return 45,000 as a way of saying, hey, this is something I've come up with. This is not a MySQL. This is not a SQL thing like, unknown table or a syntax error or something. This is something that I've defined, and I've set the message. So signal, SQL state, in quotes, 45000 is what we'll have anytime we want to throw an error. Then we have set message text, And that's important. That has to be set message text. It can't be set anything else. Set message text equal to whatever message we want returned alongside that. And then if we go look at what happens, just to refresh your memory up here, when we try that, we get error, here's our SQL state, and then must be an adult. So that's the basics of this kind of new stuff in here. But then we move on to what the heck is going on here with this delimiter, $, and then $2 here, and then delimiter semicolon. What is that? So basically, if we take a look at, let me go to a cleaner version of this back here. If we take a look at the code, we have semicolons in certain places. That's because these are multiple line statements. So we need a semicolon after something like setting message text or an if statement or this begin and end. And if we just used a semicolon and didn't have this delimiter, so just pretend this isn't here, all of this, each of these lines would be treated basically as the end of our code. Remember that when MySQL sees a semicolon, by default, that is the delimiter, and that basically means this is a signal that I'm done with this line. Go ahead and execute it. But we don't want that to happen. So we don't want this thing to be read in, and it gets to this first semicolon and it says, all right, time to execute this. This is the end, because it's not, in fact. So what we do instead is change the delimiter temporarily to, and it doesn't have to be $. I've seen people do it with slashes. $2 is most common though, just because it's not used anywhere else. So delimiter space $. That says, okay, from here on out, the actual delimiter is $2. So the end of our code is when you see $2. So then all of this is treated as one chunk. We hit the $. That says this is the end. And then we can change it back to a semicolon. If you didn't have this line, which I've done before accidentally, so we can actually do this now in the console. You can just change the delimiter anytime you want. So if I run it now and I try and do, let's say, select star from users, semicolon, and I hit enter, nothing happens. And that's because it thinks that I'm still going. It hasn't hit the delimiter. So I add $2, which now says we've hit the end. So you have to use $signs now, which can be kind of annoying if you forget. So you can see that now replaces the semicolon. However, we don't really want that. So I'm going to go back and just change it to semicolon, and now semicolon works. So that's all you need to know about the basics here. There's kind of a lot of pieces, but the most important thing, the template for any sort of trigger that you do usually has delimiter up top, and then you're using the $signs or whatever you set down here. And then you have create trigger and a name. Then you have a time before or after, an action or an event, insert, update, or delete. And then you have a table. And then for each row, begin and end, those always are the same. And then you have something happening inside of there. And just to summarize, new refers to the new piece of data, the new row we're trying to insert. And then SQL state, signal, all that stuff is just involved in sending an error message back. It's kind of a lot, but going forward, so we have 2 more examples. We're not going to spend a lot of time on the nitty-gritty details. We're just going to get going and just see how they work. Because honestly, whenever I create a trigger, I just go up to an old one that I've done before, I copy it, and then I tweak it. I don't start from scratch like I would with creating a table. You just don't do it that often. So no pressure to feel like you have to memorize all this or take it all to heart immediately. Just kind of be comfortable with understanding it if you see code in front of you. All right, welcome back. So we're continuing on with triggers. We're going to take a look at another potential trigger we could write. And in this case, we're going back to the Instagram data, which hopefully is fresh for you. It was just the last section. It's been a couple of weeks for me, so I had to refresh my memory on how the data looked. But basically, we're going to focus on one table, which is the follows table. So remember, we have users, and they can follow each other. It's a one-way relationship, unlike something like Facebook. It's like Instagram or Twitter, where I can follow someone, and it doesn't matter if they follow me back. So right now, all that we're storing is a follower ID and a followee ID and created at potentially. But really, it's those 2 IDs that are important, both foreign keys. What we want to do is prevent users from following themselves, which is something a lot of people have commented on. It's a pretty I mean, it's a logical thing to want to know about because it seems like a pretty big flaw right now with our schema. But again, just like the previous trigger example, the validation of age, this is another situation where there is more than one way to solve the problem. You don't have to do it on the database side of things. You can do it on the client side or in the application side of things. Basically, rather than sending the request to the database to insert, a new follow with the, let's say I have ID 5, where follower ID is 5 and followee ID is 5. You could just prevent that from being sent in the first place by checking on the client side. But there are certain situations where you would want to do this. And one is this case where we're not working with external code. We're not working with another application. We're only doing MySQL. So I'm kind of doing this because a lot of people have been asking about it, but I'm not fully endorsing this as the best solution in an actual application. But for us, it's really the only one that works. And it's a perfect example of doing a validation with triggers. So what we want to do is just check. Basically, when something is being inserted, a new follow is being inserted, check if the follower ID is equal to the followee ID. And if that's the case, throw an error. Okay, so I'll hop over to Cloud9. And the first thing I'm going to do is actually copy over the old starter data file from the Instagram section. Now, you can just add this to your existing Instagram database, but I'm going to keep it separate just so that if people are following along and looking at the code from the previous section, they're not getting confused about this trigger stuff, which they haven't encountered yet, but not all that important. What I'm going to do is just make a new file here. I'll just call it ig.sql. Paste all of the stuff that creates the tables and the starter data. Again, you don't have to do this. You can just work with your old database. But now I'm going to source that file. Source ig.sql. Perfect. Takes a little bit because we're inserting a bunch of rows. But now if I do show tables, oh geez. Remember, I have a screwed up wrist. I'm blaming that for my typing. You can see we have all these tables. So to illustrate the problem really quickly, I could do something like insert into follows, and we'll just do follower ID, comma, followee ID, just like that, values, and let's just pick an ID. We're just going to assume that someone has the ID of 4. I don't actually know that for a fact, but I'm pretty sure somebody does. So if we do that, no problem. So our goal here is to prevent that from happening. We don't want someone to be able to follow themselves. So I'm going to go ahead and make a new file to write our trigger inside of, and I'll just call it igtrigger.sql, or triggers in case we have multiple later on. Okay, and then inside of it, I'm going to copy this boilerplate starter code that I provided, just so that we don't have to type all of this from scratch. We can kind of fill in the blanks. So we change the delimiter to $. Then we're going to create our trigger, and we'll just call it prevent self follows. And the table name, we'll start there, is follows. Now the two most important parts are when this happens, basically the time, is it going to be before or after, and then what event, what change to the follows table. So we know we want to have it happen on insert. So when something is inserted into the follows table, and we want it to happen before the insert because we want to check if we're going to insert it or not. If we do it after the fact, it's not very helpful because the data is already in there. So we're going to have before, and then the event is insert on follows for each row, begin and end. We fill in our code here. So the actual logic here is actually pretty straightforward. All we want to check is if the follower ID of the thing that's attempting to be created is the same as the followee ID. So that's going to be an if statement. We'll have an if, and then we can use new dot follower ID, the order doesn't matter, equals new dot followee ID. If that's true, then we'll have a then, and I'll also add in the end if with our semicolon. So if that's the case, we'll do the signal SQL state 4,500 or 45,000, and we'll also do set message text equal to, and we'll just say something like, you can't, oops, need to watch our quotes there. You cannot follow yourself, just like that, and add our semicolon. All right, so we can save that. Now let's see if it works. So to run this, we're going to source ig triggers.sql. Make sure we've saved the file first, and we spell source correctly. Missing the L on the end. Okay, so it looks like it worked. Let's try another insert. Instead of 4 and 4, let's do 5 and 5. And we get, you cannot follow yourself. Great, that's good. Let's just make sure that we still can follow things how it's supposed to work. Oh, well, that's a duplicate entry. How about 7? Oh, come on. These already follow each other. How about, okay, let me pick something maybe that hasn't followed a bunch of people. 4, 2. Oh my gosh, they're all following each other. Well, all right. Took me a second, but I went back and looked at the data. Seems like this should work. 7 doesn't follow many people. There we go. Sorry about that. So basically all of this was a problem just because we had a lot of people already following each other. So I had to find some combination that wasn't already following each other. So 7, ID of 7 now is the follower, 2 is the followee, and that worked. But if we tried to do 7, 7, can't follow yourself. Okay, so that's that. The solution is here as well on the slides if you want to take a look. So to wrap things up, we used before insert again. So that's a common pattern if you're doing a validation. And we used new to compare the incoming new follow entry, the new row, the follower ID to the following ID. And then this is basically the same. So there's a lot of kind of boilerplate code that you can copy and paste. Hopefully you see that by now. So we have one more example coming up, which is a little bit different. It's not so much a validation. We're actually going to be inserting data into another table inside of a trigger. All right, so our final example here, as I mentioned, is a little different. We're not just going to be validating data before it's inserted. We're actually going to create new data based off of another action. So we're working with Instagram still, but the idea is that we want to keep track of when somebody unfollows somebody else. Right now, when a follow is deleted, when that entry is gone, it just disappears and we don't have a record of it, which is typical. That's how most databases work. But sometimes there's information that you would want to keep, that you might want to store, so you could refer back to it later because it could be meaningful. So in a site like Instagram, if there's a pattern to people unfollowing certain companies or other users, and you can discern that pattern, that's potentially really important to figure out why people are unfollowing or when these mass unfollow events happen. It's valuable information. So the idea is that rather than doing something before an insert like we've been doing here, we're going to do something actually after a delete. So after a follows is deleted, we're going to insert a new row into a separate table that doesn't exist yet. So we're kind of going to be transmitting it from one table to another. Now, you could argue there are other ways of doing this. You could, instead of creating a new entry in a table, you could take the original follows table and have a status active or deactivated or following and unfollowed or something like that you could toggle on and off. There are merits to that. There are merits to both sides. But because this is in the trigger section, it's a great example. And it's a really common application, just logging information, logging events that happen. It's probably the most common use for triggers. So hopping over here, what we need to do first is actually define a unfollows table. So we have our follows table. I'm just going to copy the entire thing and change it to unfollows. And we'll keep it as follower ID and followee ID. That's fine. Created at, everything else can stay the same. Now we have basically a duplicate table just called unfollows, and it will start off empty. But then let's say, someone with ID of 5 is following someone with ID of 6, and then they delete that, or we delete it because they've unfollowed them. We would then take that and insert it into the unfollows table. the same order. Follower ID and followee ID are the same. But then we have a time created at for when that event happened, when the unfollowing happened. So that's pretty much it. Now what we want to do is have it happen automatically whenever a follows is deleted. So first things first, I'm going to rerun this file. I'm dropping the database, creating it again, using the database, and then creating all these tables, inserting all this data. You don't have to do that. If you just want to follow along, just run this code here. Okay, source ig.sql. Perfect. So we've got that new table. If we take a look, unfollows, and it's empty. You'll just have to trust me on that. So what we want to do now is actually create our new trigger. So we could do it in the same file. I'm going to do it in a separate file just so it's easier for you to see if you're going through my code here. So we'll call this the unfollows trigger. Perfect. And I'll go ahead and copy this starter code again and paste it in. So the trigger name, we could call it anything. Let's go with capture unfollow or something like that. And what we want to do is, rather than doing it before something is deleted, we can do it afterwards, because maybe there's a problem. Potentially something wouldn't be deleted. I'm struggling with a good example, but there could be some situation where the delete doesn't actually go through, in which case we don't want to create an unfollow. So we're going to do it after something is deleted. So after delete on, the table name is follows. That's our follows table here. So when one of these is deleted, immediately afterwards, our code goes in here. And all that we want to do is insert into the unfollows table, just like this, insert into unfollows. Then we'll have follower ID and followee ID. There we go. And then our values. And the question is, what are those values? Just like before, where we had new.follower ID and new.followee ID corresponding to the new row that's going to be inserted. When something has been deleted, we have access to old.follower ID, comma, old.followee ID, just like that. So this works on its own, but I'm actually going to show you another syntax that I like for this situation, which is using set. So the set syntax is another way of inserting something. Actually, we'll just go to my solution to show you. It looks like this. Insert into unfollows, and then we have set follower ID equals old.follower ID, comma, followee ID equals old.followee ID. So it's really up to you what you prefer, but I just wanted to show this syntax. There we go. Just like that. So essentially all you're doing is using an equal sign to assign them rather than values, parentheses, that old syntax that we're used to. So I'm just going to mix it up here. But to be clear, you absolutely can use the other example as well, the typical insert. So we don't need an error message or anything here because this isn't a validation. We're not responding with something. We're not preventing something from happening. All that we're doing is connecting these two tables so that when something is deleted from follows, an analog is created in unfollows, which, as I said, is a pretty common situation, not follows and unfollows necessarily, but capturing kind of metadata or capturing other information based off of SQL happenings, if you will. So events, things changing, being deleted, updating, that you're then capturing and logging somewhere else so that you can refer back to it. So you usually don't just do this willy-nilly. Typically there's a reason you want to store that information. Otherwise it can get bloated very quickly, especially if you have a lot of triggers going on. I'm actually going to spend a couple seconds at the end of this section with some advice about when to use triggers and when not to use them and how they can get out of hand. But for now, this is perfect. So let's save it, make sure we don't have any syntax issues, and let's see what happens. So we'll do source unfollow trigger.sql is the name of the file. looks like it worked. So let's verify right now. Select star from unfollows, nothing there. Let's do a select star from follows, and let's limit it to 5. If I can spell that correctly, select. Okay, so what we're going to do is say that follower ID 2 unfollows person with person with ID of 1. So we're going to delete this right here. So let's do it now. We'll do a delete from follows where follower ID equals 2, and we could just leave it at that, and that would delete all of these that have follower ID of 2. So we'll do and follow E ID equals 1. I need that D there. There we go. Okay. So it should be gone if we select it. Now it's gone from there. And if we looked at unfollows, there we go. We now have follower ID 2, followee ID 1. So just to show you that one more time, let's go ahead and delete all follows where follower ID is 3. So that should be quite a few. 99. And now if I look at all unfollows, we have 99 new entries. So pretty cool, very easy way to kind of transfer that data over into another form. And you're not always strictly duplicating data like this. Sometimes you're summing data together. So when something is inserted or deleted, maybe you're keeping a tally in another table somewhere. Maybe you're keeping a total, like if you have a shopping cart, you have a cart table, and then you have, your items or your products table. And anytime a product is entered into a cart, anytime a new product is created, you're going to update the total, and you could do that using a trigger as well. So it's not just copying exact data like we're doing here from followers or follows and transmitting it identically into unfollows. But that's a simple example that makes sense in the context of our Instagram data. So that wraps up kind of what I want to do with triggers. Hopefully you see some of the possibilities around them. The next video is going to be pretty quick, just talking about how you can delete triggers, how you can view your triggers, kind of managing them. And then we'll also talk a little bit about kind of a warning around triggers. So I'll see you then. All right, so we've got one more video here, and this has to do with managing triggers, which sounds a bit like a chapter in a self-help book, but really it has to do with how we make sure our triggers are working and mainly delete them. So this is where the name of our trigger comes into play. And then also I'll end with a quick warning about triggers. So the first thing that we can do is just list the triggers that exist in a database. So we can just use show triggers to see what we have going on. And I'll warn you, this is not my warning I already talked about, but I'll warn you that what you get when you run this is kind of a mess to look at. But we can see we have in our Instagram data, we have 2 triggers: prevent self follows, and then you can actually see the code inside of that trigger. And then we have capture unfollow, and you can see that code as well. And if I switched over to the other database, I believe it was use trigger demo, and I do show triggers, we have 1 here. This is our must be adult. All right, so we have that. I'll switch back to my Instagram clone. Okay, and do our show triggers just to make sure they're still there. They shouldn't go anywhere anyways, but we've got 2 of them. So that's pretty much it to listing them. Moving on. So if I want to remove a trigger, it's pretty simple. It's drop trigger and then the trigger name. So let's go back. Let's say I want to remove this prevent self follows. I want to allow users to follow themselves. So I want to get rid of that. I'll just copy the name just so I don't have to type it. And we just do drop trigger prevent self follows. And if we do our show triggers again, it's gone. And just to verify that it works, it's not just deleting the trigger from show triggers. Let's try and trigger it, if you will, with something that would have caused a problem or thrown an error in the past. So insert into follows, and we have follower ID, comma followee. This is the worst part. Values. So let's insert something where they're the same. How about 7 and 7? No problem. So in the past, that would have been a problem because of that trigger, but it's now gone. Okay, so that's really all there is to managing triggers, or at least all that I'm going to talk about here. We can look at them using show, and we can delete them using drop trigger. So that brings me to the last thing that I warned you about, which is I wanted to just briefly address a potential hiccup with triggers. This is kind of a concern that a lot of developers have, and it has to do with debugging code, debugging applications that make use of triggers in your database. So imagine that you're a developer on a team with a bunch of people, and something's not working how you would expect it to. Let's say when you insert something into a table, you realize that actually 2 items are being created for some reason, and you have no idea why. And you might think, okay, maybe that's something happening on my side of the application. Maybe that's my code. That's something is wrong, with our logic on the front end, with our, let's say, Objective-C code. And you could scour that forever, but you would actually never get to the core of the problem if it was because of a trigger. And triggers are kind of stealth little bugs waiting to happen because you have no way of identifying that something is happening because of a trigger. It happens kind of behind the scenes. Like remember, if we go back here with our unfollow, if I can go find that, way back here. Oh boy, where is that? Here we go. Here we had 99 entries created automatically when all I did was run a single line of SQL to actually delete things. It ended up creating 99 things. Now, we knew that was going to happen, but if you have a bunch of triggers and somebody doesn't know about them on the team, or you forget about them, it can make things difficult to debug because it's basically magic happening behind the scenes, things that are hidden. Typically, when you're debugging, your code is up in front of you. You can see where the problems are happening. So triggers cause problems sometimes because of that. And the other thing I would say is that some people have a tendency to chain triggers together. So with our unfollows example, you could have another event trigger. So let's say here when a follow is deleted, we're inserting into unfollows. We could have another trigger for when something is inserted into unfollows to do something else. And you can chain them together. And there's actually situations where, believe it or not, that actually makes sense, but it's kind of frowned upon by a lot of people. So just be conscientious if you're using a lot of triggers. Typically, there's a better way of doing it without having to make use of triggers. And if there's not, then you know that it's a good use case for triggers. I'm not saying you should never use them. By all means, they're very useful. It's just that you should be conscientious about them and try and find ways to not use them. Okay, so to wrap that up, just be aware that triggers can make debugging more difficult, more problematic, because stuff happens behind the scenes. It's not explicit when something happens. And then also be aware that too many triggers can often be a problem. And you want to avoid triggers as much as you can, not at all costs or anything. I'm not saying they're bad. Just be careful with them. All right, so hopefully that answers some of your questions about triggers. Hopefully you can see the utility in them. And I know a lot of people are asking about preventing people from following themselves. So if nothing else, hopefully it was nice to see that, how you can actually prevent people from following themselves. All right.